In this video we're going to solve an exponential equation using logarithms. Now this is an exponential equation because it has variables in the exponent. That's what makes it exponential. We're going to have to use logs on this one because we can't get a similar base. We have a 5 and a 9. Just to refresh your memory, if you've gotten to this point with these kind of problems, you've probably done exponential equations where you don't have to use logarithms. And those would be the kind of problems where you can get the base the same. Say like you had 2 to the 3x equals 8 to the 2x plus 1. Now if we had this problem, we wouldn't have to use logs because we could turn 8 into 2 to the third power. And then use the laws of exponents to multiply these two exponents together. Make sure you distribute that 3, so you'd get 6x plus 3. Now notice we've got the base the same, 2 and 2. If we get to that point, we can just set the exponents equal to each other, because 2 to some power equals 2 to some power is only going to happen if those powers are equal. And then you would just finish solving this, just a normal little linear equation. Divide both sides by -3 and you'd get your answer. Okay, those are the easier ones when you can get the bases the same. This guy over here, we cannot get the bases the same, so we have to use logs. Now what we're going to use is we're going to use this rule. Let me erase all this. We're going to use a rule of logs that says if you have log base, we'll just make it, well, we'll do base b of m to the x equals x log base b m. In other words, if what you're taking the log of is to a power, so we've got log base b of m to the x, you could take that exponent and bring it down in front. That's what we want to do here when we have these variables in the exponent. We want to bring them down in front so that they're not in the exponent anymore and we can solve for x. It's hard to get x by itself if it's up there in the exponent. Okay, so we're going to use that rule. To use that rule, we have to have a log, so we're going to take the log of both sides. Now I'm just going to do log base 10. I'm not writing a base in there, so it's going to be base 10, and that's going to allow me to use my calculator to find the answer. So now that I've taken the log of both sides, I can take this x plus 2, this exponent, and bring it down in front, and I could take this x and bring it down in front on the next line. When I bring this x plus 2 down in front, I have to put it in parentheses because it's going to be the entire exponent, x plus 2, times log 5, and then I'm going to have x times log 9. Now log 5 here is a number, log base 10 of 5. You could punch that into your calculator and get some kind of a decimal. It means 10 to what power is 5. So we could just think of this as a number, log 5, and log 9 is another number. Alright, we need to get x by itself, and we've got x's on both sides of the equation. So what we need to do is distribute log 5 into the parentheses. So we get x log 5, that should be plus x log 5 plus 2 log 5 equals x log 9. So now these are basically two terms with x's in them, x log 5 and x log 9. We need to get those on the same side. So what I'm going to do is I'm going to minus x log 5 from both sides. And you can't like combine those and say it's x log 4 or something. You can't do that. So we're just going to have to write them next to each other. Okay, so now we've got 2 log 5 equals x log 9 minus x log 5. Now since these x's are on the same side, we can take that x out as a common factor. So finally we've got it down to just one x term. Okay, now we can use another rule here to make this a little bit nicer. On the right hand side, there's a rule that says, let's see, log base b m minus log base b n equals log base b m over n. So on the right hand side, let's use that rule with the log 9 minus log 5 to combine those into one log. So we'll get 2 log 5 equals x times log of 9/5. That's a little bit nicer. Now all we need to do is divide both sides by log 9/5 to get x by itself, and we're pretty much done. At this point, you could punch it into your calculator to get a decimal. Let's write our final answer over here. We've got 2 log 5 over log 9/5 equals x. That's the answer. That's the exact answer. If you want to get an approximation, you can punch it into your calculator and see what you get. Make sure when you punch that into your calculator, you use, if you're going to do it all at once, you use parentheses around the top. Otherwise, it's just going to take log 5 divided by log 9/5 and not 2 log 5. I could punch that in real quick and get an approximation so you can check it. So we got 2 log 5 divided by parenthesis. Well, you probably don't need a parenthesis on the bottom, but it never hurts. Log of 9/5 or 1 point. You could use 1.8 if you want to punch it in as a decimal. So I get 5.476 approximately, depending on how many decimal places you want to go to. That's what you would get. Alright, hopefully that helps, and anytime you have an exponential equation where you can't get the bases the same, you're going to have to take the log of both sides to bring that exponent down and then solve for x.